Hey geometry students, this is going to be our 26-3 notes about set theory. So set theory in probability is going to be useful when we start talking tomorrow about probability with the word or in it. But for now, we're going to kind of describe what set theory is in terms of Venn diagrams. So hopefully you've seen a Venn diagram before at some point. The ones that look like two circles with some overlap in the middle. When we talk about Venn diagrams for set theory, we're going to call one of the circles A and one of the circles B typically. But when we talk about Venn diagrams in life, a lot of times we've got our two circles, and then each of these circles has some attributes, like this could be people with brown hair. And this one could be people in first period. So all the people with brown hair, maybe in the school or something, would be over here, and all the people that are in my first period would be over here, and people who have brown hair and are also in first period would go in the middle here because both apply to them. And then everybody out here would be people who are not in my first period or don't have brown hair. Okay, so that's kind of the basics to a Venn diagram. And then there's certain ways that we, in math, talk about Venn diagrams and sets. The first one is going to be intersection. So the way that we talk about intersection, or the way that some notation that we use with intersection, is going to be like an upside down U. Kind of looks like an N for intersection. So that means intersection. So if I wanted to talk about the intersection of A and B, I would say A intersect B. And so let's say that this is A. I'm going to use black. This is set A, this is set B. The intersection of A and B, well, if I was coloring in A, and then I colored in B, the intersection of A and B would be the area that has both colors on it. So this section in the middle would be my intersection of A and B. The part where they come together, where they intersect. And this could be done with any area. If I want the area, that's not B to be intersected with A or something like that, we can do that too, and we'll talk a little bit more about that later. But basic intersection, if you've colored both areas, then it's the one that has both colors on it. Okay. Union is another word that we use to talk about sets. Union is described with a U. That would be our notation for union. So if I want to talk about the union of A and B, it would be A, U, B. A union B. Okay, so same kind of thing. I'm going to label my Venn diagram A and B. And I'm going to color in A. And I'm going to color in B. And A union B would be the entire thing. Anything that's colored in this situation would be A union B. So it would be both circles pretty much. The thing that we'll have to be careful about when we talk about or is that using or in probability, is that we want to make sure that we don't count the middle section twice, because notice how it was colored in with A and it was also colored in with B. If we were counting all of the things in A union B, we would want to make sure that we didn't accidentally count this section twice. But we'll talk a little bit more about that specifically tomorrow. Okay. The last thing I want to talk about vocab-wise is complement. So not like compliment like your hair looks nice today, a different kind of compliment. So with this kind of complement, first off, the notation. If I wanted the complement of A, it would be A with an apostrophe. So if I labeled my sets A and B, the complement of A would be everything that's not A. So everything outside A. So it would be all of this out here. It would be all of this that's inside B. But it would not be anything in circle A. So it's basically everything besides A. If I was doing the complement of B, it would be everything besides B. Okay. So that's some vocab for us to use. Now let's go down here and try a couple. So with this one, I've already got everything labeled A and B. For this example, we are going to do, we're going to color in the complement of A intersected with B. Let's make a difficult one to start with here, or more difficult anyway. Complement of A intersected with B. So basically, what I'm going to do to figure out what it's going to be is I'm going to color in, first I'm going to color in the complement of A. So as we did up here, the complement of A was everything that's not A. So I'm going to color that in with this color. So it's everything out here, everything except for the circle of A. Then I'm going to color in B. So that's just everything in the B circle. And then the intersection of A and B, if we remember, is everything that has both colors on it. So that would be just the section that has both colors. So it would be everything that's in B, but not in A. So it would be all of this that has both colors on it. So our final answer would be just the black section there. Okay. So let's try another one. We're going to do a union example. Let's do the complement of A union with the complement of B. So everything that's not A union with everything that's not B. So first I'm going to take the pink and color in everything that's not A. Just like we did on the last one, coloring in everything that's not A. So everything besides the circle of A. And then I'm going to take the orange one and I'm going to color in everything besides the circle of B. Because that's going to be the complement of B. So I'm going to color in with orange everything except for B. All right, and then if we would go back and look up at what union is, union was basically anything that has any color on it at all is part of your union. So, looking down here, our union is going to be pretty much everything except for the middle section. So our union is going to be everything out here, because all of this has at least some color on it, either pink or orange. So the black, everything outside of the middle, is going to be our union of the complement of A and B. Okay, so then we're going to go ahead and turn the page. Okay. And we're going to go down to this one. I'm going to have you guys, we're going to skip example 3 and 4. That's a little too much example space. I'm going to have you guys try one here. We're going to do A intersect with the complement of B. So pause the video real quick, give this one a try, and then start the video again and I'll show you how to do it. Okay, so here's how we would do A intersect the complement of B. So the first thing you want to do is color in everything that's A. So the first one, here's A. So A is that entire circle. And if you don't have multiple colors to shade with, try shading opposite directions. That way the section that's like crisscrossed will be the one that has both of them. Okay, so we want A intersect with the complement of B. So now I want to color in everything that's not a part of circle B. So that would be all of the stuff over here, but not including B. Okay, and then remember, intersect is basically everything that is colored by both colors. So I'm gonna get that section that has both. So that would just be this part, kind of the moon-shaped part. Okay, so that would be A intersect the complement of B. Okay, then we're gonna go and take a look at a different type of problem here. So sometimes these problems can look like this, where we have these brackets. This is known as set notation. So in these brackets, it's describing the set of A as being the numbers 1, 3, 5, 7, 9, and 11. And then set B includes 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then the sample space, so the box that A and B both live in, is all whole numbers. So then what I'm going to do first is just kind of fill in where all these numbers should go. So notice that A and B both get 1. They both get 3. They both have 5. They both have 7. They both have 9, and that's all. So then the ones that B doesn't have, but that A does have, like 11, would go over here. And the ones that B has, but A doesn't have, will go over here. So like 2, 4, 6, 8, and 10. All right, and then in the U space would be any whole number that's not in A or B. So that would be like numbers that are bigger than 11 or smaller than 1. Okay. So then we can use this to answer questions like what would be A intersect the complement of B, for example. So what numbers would live in that space? Well, we just did this one, right? We figured out what A intersect the complement of B was. It was basically everything that was in A but was not in B. So that would be just the number 11 that's in this space right here. So it would just be the number 11. We could also answer questions like how many numbers are in that space. So there would just be one number in that space. So things like that are things that we want to be able to do here. Okay, so let's have you guys try one. So we're going to do something similar to what we just did before. I'm going to give you guys a problem. You guys will pause the video and give it a try. So for this one, A is going to be the numbers 2, 4, 6, 8, and let's see, 10 and 12. And that's my attempt at making brackets. And then set B is going to be the numbers 1, 2, 3, 4, 5, and 6. And then U is going to be all whole numbers again. Okay, so go ahead and fill in where those numbers would all go, and then tell me what would A union B include. All right, so pause the video and try this problem out and then restart it, and I'll tell you how to do it. Okay, so hopefully you followed instructions there and paused the video. Here's how we would do this problem. So we know A has 2, B also has 2. A has 4, B also has 4. A has 6, B also has 6, but that's where their similarities end. Set B has 1, 3, and 5. Set A has 8, 10, and 12 all to itself. So now we want to know what is A union B. So we want to know, okay, what numbers are in A. So this is A. Union with B. So this is B. So it's basically all of the numbers that are in here. The numbers that are in U would be all whole numbers, so that would be everything out here would be like, let's see, we missed 9 and 7 and 11. And we also had any number that's greater than 12 or less than 1. Okay. So if we want to know what's in A union B, that would be basically the numbers 1, 3, and 5. Also the numbers 2, 4, and 6. And then the numbers 8, 10, and 12. And you can put them in order if you want to, but that would be the set that is A union B. And we would use set notation as well here. Okay, so go ahead, turn the page. Now we're kind of getting into the homework zone. So for homework, you're going to, for numbers 1 through 6, shade the appropriate region. There'll be a region that's labeled on top like B intersect A, and you'll want to color in that region. Let's see. So you'll find that some of these regions might have already been done in examples, so you can kind of look back at those if you need some help. And then on the back, there's 2 more problems. For 7 and 8, you're going to fill in the Venn diagram with the numbers and then use it to answer the questions like what numbers represent the complement of B intersected with A, or what numbers represent B intersect A, things like that. It might be helpful if you look back at the problems 1 through 6, if you can find where you've already shaded this region, then you can just take down the numbers that are in that region. But yeah, all right, so if you have any questions, you can either email me or hold on to them until Tuesday, and we can talk about everything then. Go ahead, get on with the homework, and have a great day. Okay, so hopefully you followed instructions there and paused the video. Here's how we would find this one. First, we want to color A. So I'm going to take the pink and I'm going to color A.